Get a countdown on this one. All right, radical expressions, aka square roots or slash, you know, radicals of some sort. Okay, square roots mainly what we're going to be dealing with today. Square roots. Sometimes they're nice square roots. For example, they'll give you the instructions simplify, and the first problem is going to be a nice easy one: the square root of 9. What's the square root of 9? Why? Yeah, because 3 times 3 is 9. The way I do these is with a factor tree, because I don't have room in the noggin to memorize every square number that ever existed. And then I don't have the mental capacity to be able to remember if every number in the world is divisible by a square number. So I use the old elementary school factor tree method for this. So when I break down a 9 with the old factor tree from elementary school, 9 is a composite number, which means something else multiplies to be that. It's 3 times 3. How many 3s are there? 2. I'm taking a square root. What's the exponent for square roots? 2. One pair of 3s is that 3 that's the answer. Now, the reason that's important is because most of the time in life, you don't always get a perfect square number. A lot of times, you're going to get a problem like the square root of 18, which we know is not a perfect square number because it's smaller. We kind of know the smaller ones, but we don't know them when they get up above 400. Right? We know 400 is 20 times 20, but past that, I don't know any. I don't know a bunch of them before 400. Okay, because you got the 19 squared. I can't remember what that is. It's 380 something, but I don't remember what. But I do know that I can take 18 and break it apart. I got different ways I can break 18 apart. I can either do 9 times 2 or 6 times 3. It doesn't matter which one. I'm going to do 6 times 3. And then I know 6 breaks apart because it's not a prime number. And it's 2 times 3. Now here's how that simplifies. So I know we could a monkey could type in the square root of 18 into our calculator and get a decimal. We're wanting a simplified exact solution out of this. So remember, we're doing square roots. So we're looking for sets of 2. There are 2 3s right there. So that's going to be the 3 on the outside of the radical. This 2 doesn't have a buddy, so he goes back on the inside. 3 radical 2 is the simplified form for the square root of 18. They are equivalent to one another. If I do the square root of 18, I get that decimal, 4.24, and a bunch of stuff after that. If I do 3 square root of 2, I get the exact same decimal. Okay? The 6 is not a prime number, so we don't pay attention to it. The only numbers that you look at on your factor tree are the prime numbers, the ones at the end of the branch. So the 6 it's like it disappears out of that. Let's do another. This is not a hard thing, but it's something we need to practice. So like 24. 24 is not a huge number, and it's pretty close to a square number, but it's not a square number. I know it didn't, 5 is 25. 5 squared is 25. So I know that's not what this is. So I'm going to break down the 24 with a factor tree. When I think of 24, I think about 12 times 2. That's the easiest way to get 24 in my book. And then I think about 12. How can I break 12 down? 6 times 2. So there's a 2 and a 6. And then I've got the 2 and the 3 here. I'm looking for sets of 2. So I'm going to use these 2 2's together. That's a set of 2. So that's going to be a 2 on the outside. This 2 right here and this 3 right here don't have a buddy. So they're going to go back on the inside and multiply together. That's going to be 2 radical 6. 2 square root of 6. Now, you may have done this a different way with whoever you had in Algebra 1 or geometry class where you most likely did this. And you may have divided by perfect squares, which is absolutely fine. But to me, I don't have to know as much. I don't have to retain as much information to do factor trees. All I got to be able to do is break a number apart and then count sets of two, which makes my life a lot easier because I don't have to memorize so much stuff. There's only so much room in the head. There's only so much information that you can absorb and be able to recall it. So I try not to fill it up with things that I can not have to memorize. There are certain things you do need to memorize. This is not one of them. Okay. Let's go to a bigger number. Let's do the square root of 108. Okay, so this one, bigger number. I don't know what square number goes into 108. But what do I know goes into 108? What multiplies to be 108? 12 and 9. I know my 12s times tables, so I'm just breaking it apart as 12 times 9. Then I'm going to break those two numbers apart. I'm going to break the 12 apart as, I'm going to do 4 times 3 this time. And then the 4 is 2 times 2. And then the 9 is 3 times 3. I'm looking for sets of 2 because I'm doing a square root. There's a set of 2 2s. There's a set of 2 3s. There's a 3 that don't have a buddy. If you don't have a buddy, you go back inside. So on the outside, I've got a 2. I've got a 3. On the inside, I got a 3. On the outside, 2 times 3 is 6. What that tells me is that 36 went into 108. I don't know how to look at 108 and tell you that 36 goes into it. Right? I mean, we just can't look at a number and do that. But I can look at 108 and tell you 12 times 9 is 108. So this method, to me, just makes this process a little simpler. It may take you a minute to break the number down, but it's really not that bad. Okay? Let's go slightly larger. Let's do the square root of 300. I don't believe 300 is a square number. If I thought it was, I would just go to the calculator and type in the square root of 300. If I get a decimal back, I know it won't. It's not. And I got to do the breakdown. Okay? Got to break it down there. So I'm breaking apart 300. What's the easiest way to break apart 300? That's one way. Not the way I was thinking of, but it works. I'd do 3 times 100, wouldn't it? That to me is that, but both of them work. It doesn't matter which one you start with. As long as the two numbers multiply to be the number above them, you're good. And then 100 breaks apart into 10 times 10, 5 and 2, 5 and 2. So I'm looking for sets of 2. So I got 2 5s, and then I got 2 2s. I got a 3 that don't have a buddy. So that's 5 times 2 on the outside, a 3 on the inside. That's 10 radical 3. Abby said that she did 10 and 30 for her 300. 5 and 2. What? 3 and 10 for the, and then 5 and 2 again. You got the same numbers. You got a pair of 5s and a pair of 2s. Same thing. Doesn't matter how you break it apart to start with, as long as your numbers multiply to be the number above it. It works no matter what. Here's a nice one, 450. Let's keep getting the bigger numbers there because I don't know much about 450, but I could come up with a way to multiply to be 450. What's an easy way? I'm thinking it ends in a 0, so that means 10 goes into it. How many times? 45. That's the easy way to break apart 450. Now, we could do other numbers, but that to me, that's the easiest way. And then I'm going to break those numbers apart. I'm going to break apart the 10. That's a 5 and a 2. I'm going to break apart the 45. That's a 5 and a 9, isn't it? And then the 9 breaks apart. 3 and a 3. So I got a pair of 5s. Got a pair of 3s. I got a 2 that doesn't have a buddy. 5 times 3, radical 2. So 15, radical 2. What's 15 squared? 225? I didn't think about 225 going into 450. I really didn't think about 225 being a square number either. That's where the 15 came from. But we found it by going through smaller numbers that were easier to deal with. So that's the trick to this, is using the smaller numbers that are easier to deal with. Okay. Let's look at fractions with square roots. Fractions with square roots. If you got a square root of 16 over 25, the way you want to think about that is take the square root of the top and the square root of the bottom. Do we know the square root of 16? Yeah, it's 4. What's the square root of 25? Ooh, done. Fractions aren't that bad. We want to get nervous when they happen because it looks like it's going to be tough, but it's just split it apart. Do the square root on the top, do the square root on the bottom. Let's do another one that's not too bad. 144 over 49. Just think about it as two separate ones. Do we know the square root of 144? 12. Do we know the square root of 49? We're done. Again, you want to know the ones up to 12 times 12. You really do want to know those. But anything past that, factor tree will work for you. Now, where it gets a little more interesting is when you have something that doesn't quite work as nicely. So maybe you've got a fraction and you've got a 28 over, let's do 28 over 25. Let's do that. That looks a lot like example G, but it's a little bit different. Okay, so I'm still going to split it apart. The good news is that the bottom one works out. The square root of 25 is 5. But the top one, there isn't a perfect square to 28, right? So that's where I've got to do my factor tree stuff on the 28. Okay? So I'm just going to break down the 28. Just going over here on a little side note, scratch paper somewhere. What multiplies by 28? Oh, yeah. Good. And then 4 breaks down into 2 and 2. 7's prime, so it doesn't break down any. I got a pair of 2's. So that's a 2 radical 7. Not crazy hard there. Let's do 147 over 64. Okay, so when you split it apart, 147 over the square root of 64, and Abby says that's 8, which is absolutely correct. 8 on the bottom. But 147, let's start breaking that apart. Does anybody know the trick to know how a number is divisible by 3? Y'all know that little trick. The math trick for knowing a number is divisible by 3. Add up the digits. 1 plus 4 plus 7 would be 12. Since 12 is divisible by 3, 147 is divisible by 3. Same rule works for 9. If you add up the digits and that sum is divisible by 9, the number is divisible by 9. It's kind of a neat trick. So I know 3 goes into that. How many times 3 go into 147? 49. Ooh, that's nice. So that's 49 is a 7 and a 7. So I got a pair of 7s and a 3 left over. And there I have simplified that. So that's mixing together the split the fraction into 2 pieces and then just work them out like that. Same thing would happen if the bottom part wasn't a perfect square. Just break it apart and simplify it a little bit. All right, next thing, same section, JK, is multiplying radicals together. Square root of 6 times the square root of 12. The rule is you multiply outside times outside, inside times inside. Well, on these two, there's not anything on the outside. So all we got to do is multiply 6 times 12 on the inside. So that's really the square root of 72. And then I'm going to break it down the same way I've been doing it. Break down 72. I got it from 6 times 12, so I'm not going to really stretch myself to work on that. And then I got a 3 and a 2, a 3 and a 4, and 4 is 2 and 2. So 72, I got a pair of 2s and a pair of 3s. 2 times 3, radical 2. Ooh, what happened there? There we go. So that's going to be a final answer of 6, radical 2. So if there's things on the outside, you multiply those together. Things on the inside, you multiply together. But then you got to simplify after you do that. Or at least see if you can simplify. Let's do one that's got some stuff on the outside. 3 radical 8 times negative 5 radical 12. So when I multiply that together, I'm going to multiply 3 times negative 5. And then on the radical, I'm going to multiply 8 times 12. So I'm writing an extra step there. You probably would never write this step down. But I'm writing that down so you know where the numbers are coming from. Okay, so on the front there, I've got a negative 15. And 96 on the inside. I'm going to break down the 96. So I'm going over here and I'm doing a factor tree. 96, I got it from 8 times 12, so I'm just going to use that. That's going to be 4 times 2, that's 2 times 2. 2 times 6, and that's 3 times 2. So I'm looking for sets of 2. I got a set of 2s there. I got a set of 2s there. But then I got this 3 and this 2 that don't have a buddy. So on the outside, I got the negative 15 that was already there. And then what else do I have? Not a 3 and a 2 on the outside. I have a 2 on the outside. And then another 2 on the outside. On the inside, I've got the 3 times 2. So maybe I should do different colors there. Let me do that. This set of 2s is that purple 2. This set of 2s is that red 2. That 3 and that 2 are the green ones. That negative 15 was already there. So I've got to multiply it times that 2 and that 2. So negative 15 times 2 is negative 30 times 2 be negative 60 square root of 6. A lot going on when there's multiplying with stuff on the outside and on the inside. Let's do one more. See if we can get this one. Negative 8 radical 20 times negative 10 radical 32. What's on the outside? Negative 8 times negative 10. On the inside, I got 20 times 32. So on the outside, I'll simplify that a little bit. That's going to be 80. On the inside, I can simplify that a little bit. 2 times 32 is 64. Add a 0. That's 640. Check yourself with the calculator if you're not feeling very confident tonight. 32 times 20. Yeah, it's 640. And now, break down the square root. $640. I'm going to do 64 and 10. That's 8 and 8. 4 and 2. 2 and 2. 4 and 2. 2 and 2. 2 and 5. I'm looking for sets of 2. 1, 2, 3. Then I got a 2 and a 5 left over. So I've got the 80 that was there to begin with. I've got 3 2s. And then underneath the radical, I got 2 times 5. So that simplified quite a bit there. Because all I've got left in the square root is a 10. On the outside, I got 80 times 8, which happens to be 640. 80 times 2 is 160 times 2 is 320 times 2 is 640. Radical 10. The process doesn't change any the whole way. I mean, it's just you got to multiply it together, outside times outside, inside times inside, and then you go do your factor tree. That's the way you want to simplify those. Okay. That's all of R7. One more section. Complex numbers. Okay. Complex numbers are kin to what we just did in R7. Complex numbers come from the square root of a negative 1. The square root of negative 1 is I. Okay, so anytime you see a square root of a negative, you know an I is going to simplify out of it. If you square I, that's going to be negative 1. If you cube I, that's going to be negative I. And if you have I to the 4th power, that's going to be positive 1. That little chart right there, you need to memorize that. That's going to be important to know. Those 4 things for sure. Okay. A complex number is written A plus BI. This A is the real part. This BI is the imaginary part. Now, imaginary is kind of a bad name. I took a class in college called History of Mathematics. It really was probably one of my favorite classes. One, because the professor was awesome, and 2, because it was so interesting to hear how things came about. Why did we do it the way we do it now? So we learned that stuff in that class. And when we talked about imaginary numbers, what it was is a couple of mathematicians were writing letters back and forth to each other because they didn't have text messages or anything like that, couldn't FaceTime one another. So they were writing letters back to each other, and they were challenging each other on how to do problems. And they were working problems together, and they got to solving these equations, and they knew that every time you had x squared in a problem, that you would find 2 answers with that. Sometimes when they would work them out, they couldn't find them but they knew there should be 2 because it had x squared in it. And they would say, okay, I've worked this problem as far as I can. I know that there are 2 answers. We'll call them 2 imaginary solutions. Because I don't know what they are, but I know they should be 2. Because every other one that I've ever done that had x squared in it had 2 answers. So they started just calling them imaginary answers. That name kind of stuck. And we still call them that today. Now, we call them complex numbers most of the time in modern mathematics, but imaginary is still part of the nomenclature for this. So imaginary numbers, not imaginary as in they don't exist, imaginary as in from the square root of a negative is where the imaginary part comes from. Okay, so when we're doing these, it's going to be very similar to what we just did. Okay, so we're going to do some simplifying of radicals first. So in the first part, we're going to do simplifying radicals. So we're going to do something very similar to what we did in R7. But I'm going to put a negative on it. The negative, the only thing it changes is I'm going to put an I on the outside of the radical. Everything else about it is exactly the same. I'm going to do the factor tree for 24. I'm going to do 6 times 4. And I know 6 is 3 and 2, 4 is 2 and 2. And I'm looking for pairs. I got a pair of 2s right there. I got a 3 that doesn't have a buddy and a 2 that doesn't have a buddy. So on the outside of my radical, I've got a 2. Because it was a negative, I've also got an I. And then on the inside, I got the 3 and the 2 that I'm going to multiply back together. So that's going to give me 2I radical 6. The only thing that changed about how we did that compared to what we just did in R7 was the negative. It added an I on the outside. That's not bad. That means that's the only thing I got to remember. If I understood R7, this is not bad. Let's look at this one. The square root of negative 84. Okay, so I have an 84. I've got a negative on the 84. So I know that when I write this answer, I'm going to have an I in front of my radical. I can go ahead and say that. Now I need to break down the 84. I don't worry about the negative anymore because I know it's just going to be an I. So I'm breaking down 84. What multiplies to be 84? 12 times 7. That's kind of nice. Because 12 breaks down. How do you want to break down 12? 6 and 2 sounds good. All right. And I'm looking for pairs. Got a pair of 2s. So there's a 2 on the outside with the I. What's on the inside? 7 times 3. That's 7 that doesn't have a buddy and the 3 that doesn't have a buddy. So 7 times 3 or 3 times 7, ever how you want to write that. So that's going to be 2I radical 21. You're done. Remember, if it's not at the end of a branch, you forget about that number. It's not part of it. Okay. That's not too bad. Let's say we had the square root of negative 35. That looks like a fun one. Not a big number, but a lot of fun in this one. I like it. So, what do I know is going to come out of the radical? An I. I know that off the bat because it's got the negative inside of there. Now I'm going to figure out if there's anything else that comes out with that. So break down a 35. Okay, 7 doesn't break down any further. 5 doesn't break down any further. So I don't have any pairs. Multiply those back together. I radical 35. Boom. The only thing that came out was the I because there were no pairs. That's nice. That's not too bad. That's doable. I saw a was looking for neon signs for my classroom at school today, and I found one that said everything is figure outable. I thought, man, that would be awesome because number one, it's true, and number two, it would make the English department really mad because it's not a word. And I almost ordered it, but I didn't because I thought, that's probably not good advertisement for our education system to put a word out there that doesn't exist. Figure outable. So I've got a -3 hanging on the front already and a -132 on the inside. So what do I know off the bat that's going to come out there with that -3? An I. So I've got the -3, and then I've got an I, and then I figure there's some stuff left inside the radical because the 132 I know is not a perfect square. So I know there's going to be something left over in there. So I'm going to break down the 132. What multiplies to be 132? How much? 11 and 12. I like it. Way to know your multiplication tables. And then 12 breaks down into 6 and 2. That's a good way. And all right, so what have I got?
2 and 2. The 3 and 11.
Yeah, I got 11 and 3 is going to go back inside and multiply back together to get 33. And on the outside, I got to add that times 2 in there. What's my final answer? Yeah. We're getting better at this. That's good news. Now, let's look at this one. And I'm afraid I'm going to blow your mind a little bit. Now, we did a problem very similar to this in R.7. How did we do that? Before we broke them down, when we're multiplying together, what do? We multiply the stuff on the inside together and the stuff on the outside together, right? The problem with this one is the fact that they're negative on the inside first. One of the pitfalls on this is you don't multiply -12 times -8 because in order of operations, before multiplication happens, exponents happen. And a square root is a sneaky exponent. Because it doesn't look like an exponent, but it is. Okay? So we've got to take care of the I part first. Okay? So this is going to be I radical 12, and this is I radical 8. When you're multiplying them together, if there's a negative on the inside, take care or tackle the I's first. Okay? Make sure you tackle the I's first. Get those first. If you're fighting somebody bigger than you, go for their eyes. They can't see you, they can't whoop you. I'm not condoning violence, but if someone were to come after you, go for the eyes. It's always a good way to get rid of them. You start messing with somebody's vision, they don't like it. All right, so tackle the eyes first. Then multiply it together. So I have I times I on the outside, and on the inside I got 12 times 8. What's I times I? Very good. And then I squared is what? -1. So that's going to come back. Remember that table at the beginning I said you had to memorize? That's where that -1 comes from. And then 12 times 8 is 96. So I got to break down that 96 now. So factor tree on the 96. I got it from 12 times 8. That's 4 and 2. That's 2 and 2. It's 2 and 6. It's 3 and 2. So I got one pair of 2s, two pairs of 2s. Then I got a 3 and a 2 that don't have a buddy. So that's going to be negative 1 times 2 times 2, radical 3 times 2. That's going to be negative 4 radical 6. Remember that I squared is equal to negative 1. That's the most common one you're going to see in this, but it is something that comes up. Let's do another one. Let's say we had negative 3 radical negative 20 times 5 radical negative 10. So remember, tackle the i's first. Go for the i's. So this is going to be negative 3i radical 20 times 5i radical 10. Important. Go for the i's. Now, multiply that together. So it's outside times outside, inside times inside. So that's going to be negative 15 I squared radical 200. I know that I squared is what? Negative 1. So this is really negative 1. So what is negative 15 times negative 1? Positive 15. Now I'm going to break down my 200. 2 times 100. 10 and 10. 5 and 2. 5 and 2. Got a pair of 5s. Got a pair of 2s. So I got a 15 times a 5 times a 2. Radical. There's a 2 that doesn't have a buddy. 15 times 10 would be 150. Radical 2. Isn't that fun? That's about as tough as they're going to get. They're not going to get just crazy hard on you in this section. I mean, just having a bunch of i's in there. Remember that I squared is equal to negative 1. That's the key to being able to work those things. Okay. All right. Next thing is adding, subtracting, and multiplying and dividing complex numbers. It's the last thing of the night. So operations with complex numbers. The last thing of the night is probably the easiest thing we do. Okay. When you write your answer, you want your answer in this form, A plus BI. The plain number first, the I part second. That's the way you want your answers to be. That is called standard form for a complex number. That's the way you want your answers written. Okay. So let's take an easy one first. 3 plus 5i plus 6 minus 2i. What do you think you put together? The i's go together, and then the regular numbers go together with the operation that's between them. So we're going to multiply, or we're going to add 3 plus 6. Those are the like terms there, so that's 9. And then 5i plus negative 2i would be plus 3i. Boom. You're done. Now, I'm going to show you that the calculator will do complex numbers with you. I don't ever do addition with the calculator because it takes me too long to type it in. But I'm going to show you that you can check your work with it. So on the calculator, your calculator understands what I is. Okay, and if you look down here at the decimal point, right above the decimal point in blue is a little lowercase I. That's the I that it understands it's a complex number. Okay, so I'm doing parentheses 3 plus 5, and then to get the I, I'm going to hit second and decimal point. Close the parentheses. Plus parentheses 6 minus 2, second decimal point to get the I, close the parentheses. And if you hit enter right here, it's going to work this out, and you should get 9 plus 3I. Woo! Isn't that nice? Get the complex number done for you. So if you want to use the calculator for this, I'm okay with that. There's nothing wrong with it. You've got a tool in your hands that works, that does that. So you can do that. Okay? Example H. Let's do 3 plus 5I minus 6 minus 2I. Guess what you do? Subtract the like terms. What's 3 minus 6? Negative 3. What is 5I minus negative 2I? Plus 7I. Very good. If I go to my calculator and I type in 3 plus 5I minus parentheses 6 minus 2I, I get negative 3 plus 7I. Your calculator has that code written into it as part of its normal calculator function to be able to do the complex numbers for you. It's really nice. Okay. It isn't as nice on adding, subtracting as it is on multiplication and division. I'll show you how to do multiplication division by hand, but then I'm going to show you with the calculator. I do use the calculator a lot to do the multiplication and the division because it is so much faster. Not because I can't do it, it's just because it's so much faster, and I just need an answer out of it. Okay? So, example I. Imaginary numbers. I. Let's do 3 plus 5I times 6 minus 2I. This looks a lot like what we did in R3 back at the beginning of the evening. It's just multiplying. So if I was going to do this by hand, I would go 3 times 6 is 18. 3 times negative 2I is negative 6I. 5I times 6 would be plus 30I. 5I times negative 2I is negative 10I squared. This is where knowing I squared is really negative 1. So this is really 18 minus 10 times negative 1 plus 24I. Well, that's going to be negative 8 or 18 plus 10, which is 28 plus 24I. So that I squared turning into a negative 1, it changes that to be a positive 10 right there. So that's 18 plus 10. That's where the 28 came from. The positive 24 was 30, and a negative 6 added together is positive 24I. Now that's doing it by hand. That took 1, 2, 3, 4, 5, 6 operations to get there to happen. I'm going to type it in on the calculator and make sure that's correct. So I'm going to put parentheses, 3 plus 5I, so second decimal point to get the I. Then I'm just going to do parentheses, 6 minus 2I. I get 28 plus 24I. Same answer, much faster. Much, much faster. So multiplying complex numbers together, I usually do that with the calculator just because I'm looking for the answer there. I'm not really doing much with that at this moment. So doing it by hand doesn't really gain me much. Now, the last operation is division. I'm going to do this one with the calculator first. And then I'll show you the long way, the hand way of doing it. That's a joke. So on the calculator, I'm going to put in a fraction. So alpha y equals the fraction button. On the top part, I'm putting 3 plus 5i. 3 plus 5i. Then I press the down arrow to get to the bottom part of the fraction, and I'm going to put the 6 minus 2i. Second decimal point to get the I. Then I'm just going to hit enter. And it does that division for me and gets me 1/5 plus 9/10I. I highly advise doing the division with the calculator because it is the most tedious of all of the stuff. Okay? I'm going to show you how to do it by hand because I feel like as a math teacher I need to. The way that you do this is you multiply by what's called the complex conjugate. That just means change the sign in the middle of the bottom. 6 plus 2i. 6 plus 2i. 6 plus 2i divided by 6 plus 2i is the same thing as multiplying by 1. So it's not changing the value, it's just going to change how it looks. So I'm going to multiply that together on the top, like with my distributed property stuff. So that's going to get me 18 plus 6i plus 30i plus 10i squared. On the bottom, I'm going to do the same thing. I'm going to multiply that together. That's going to give me 36 plus 12i minus 12i minus 4i squared. Then I simplify that. So on the top part, this becomes minus 10. So that's 8 plus 36i. On the bottom part, these 12 i's cancel each other out, and this becomes plus 4. So that's 40 on the bottom. Then I split it apart. 8 over 40 plus 36 over 40. And then I simplify those. 8 goes into itself once and into 40 5 times. 36, 4 goes into 36 9 times. 4 goes into 40 10 times. That's the same answer I got by doing it with the calculator, but it was a lot more work. So adding, subtracting, I probably am not doing that with the calculator because I can do it quicker without it. Multiplying and dividing, it's got a lot of stuff in it, and I probably am doing that with the calculator. And that's absolutely fine. Math 100, that's absolutely fine. Nothing going to come back to haunt you if you do that with the calculator because you're going to do the same thing in 110 with it too. Okay? So suggested problems for this material. On R3, it was 45 through 85 odds. R4, 1 through 45. And then you skip a few and you got 51 through 69. R7, 17 through 79. Odds on both of those sets. And then the last one, the 1.3, that was the complex number stuff. That was 1 through 37 in that section. Remember, next week we are not meeting. We are on fall break next week on Monday and Tuesday, so no class. You'll have quizzes from this week's stuff, and they will be due the next Sunday night. So you'll have 2 weeks to complete them. I probably wouldn't wait until the second week to do them, but anyway, just make sure you got that done. If you borrowed a calculator, please drop it on the desk on the way by so that we got those for next time. Hope you have a great fall break. Enjoy your time and get your math done.
I want to ask you.
What's up?
I didn't want to interrupt the class.
Oh, that's okay.
Since I've got a T, I've got 83.
Yeah, it does everything.
I didn't know how to do the fraction part.
It doesn't have a fraction button.
It does.
No.
$100.
Yeah, that's not. That's the only thing it doesn't do.
Can you still get an answer for if you divide it?
Yeah, yeah. If
how
so,
do you do
like here, let me show you. It's been a while, but I think I can do it.
All right.
All right, so come around. I'll show you. So if you do, you did 5 divided by 3. That's a decimal, right?
Right.
You hit math, enter, and I'll change it to fractions. Now, if you do the complex number stuff, so if I'm doing this problem here, we had 3. So the difference is what I've got to do is I got to put the top in parentheses, 3 plus 5 I, and then divided by open up another set of parentheses and do the 6 minus 2i. And then when you punch that enter, it's going to give you decimals
Okay.
there. But if you hit math, enter, it writes them as fractions, but they're sideways instead of up and down.
Okay,
So it
awesome.
still does them. It just doesn't have the fraction button where you can write it
right.
as a big fraction. You just got to do parentheses around the top, parentheses around the bottom.
I'm glad it can work out. For
Yeah, it does.
It scared me.
I grew up on the 83, so I remember how to do a lot of things on the 83 out of habit, just because I've done so much.
I knew about the fraction option. I tried it earlier though, and it gave me the I forgot about the parentheses. And
Yeah, the parentheses will get you on that. So yeah.
Thank you.
Yeah, no problem, Max. Have a good week. Okay. Thank you very much.
The next time you send me, I'll be 24 and I'll have a handgun.
Hey, all right. Two good things. Calculated for your birthday, right? Have a good one. Yeah, there you go.